Hello and welcome to this new video on my channel. My name is MrGrey and I'll be taking you through some entertainment. On today's video, I'll be applying some crazy theories on our planet Earth, and those theories will all lead to one certain result, which is life vanishing from our beautiful planet. So let's get started. So the first thing we're gonna experiment, as we all know, planet Earth is almost as big as planet Venus, but they are really different from each other. What I want to do is change the atmosphere of planet Earth and give it exactly the atmosphere of planet Venus. Let's see how our planet will react to that. This is Venus. We terraformed that and made it habitable in a previous video. What I'm gonna do is just go to the properties, surface of Venus, scroll down to the atmosphere, and I'm going to copy this number. All right, I'll just copy it. We need to also take a look at the number of layers. Venus has 225 atmosphere layers. Let's get back to planet Earth. All right, let's pause time first. Let's go to the properties of our planet, surface, okay, and scroll down to the atmosphere, and let's copy the number we have just pasted. Okay, now the change is huge. Normally planet Earth has one Earth atmosphere mass, but now it has about 95 Earth atmosphere mass. So that is huge. Regarding the number of layers, due to universe sandbox, there are only 3 layers of the atmosphere. We're gonna change that to 225 layers. All right, time is still paused. We will just check this the overview in the properties of the planet. We're gonna start time and let it run. Now we are going second per second, which means we are going real time. I'm not increasing the time yet. I just want to scroll and see life likelihood has dropped to 1.55. It was, I forgot to show you, but it was 97% on planet Earth. Life likelihood is 97%. It's not 100%. I don't know, maybe because there are some areas not habitable on our planet, or maybe because of the global warming. I have no idea why is it not 100%, but it dropped from 97 to 1.59%. That is crazy. And let's now speed up time. All right, let's hide the atmosphere individuals. So the atmosphere is there, but as you see, I mean, well, what are the changes actually? Let's check what are the changes. Okay, this is Egypt, and in Egypt, this is the Nile. The Nile River has gone dry, and I don't know, it's gonna get even drier. Let's even increase time more, speed up time, and check the result in the future. How is it gonna be? Of course, this atmosphere will make a crazy global warming, and as you see, the temperature is rising. So we are now in 2025. Average temperature is 43 and increasing. Let's go to the surface and check the temperature. At highest, it's gonna be about 60, lowest minus something, but that's all rising. Life likelihood is still the same. Okay, let's pause time and check what is happening to the planet. Again, the atmosphere is still there, but I've just hidden it from the visuals, as you see. Yeah, there are basically major changes in those seas and oceans. Yeah, that is not looking good. That's Southern America. Yeah, and of course the temperature will keep on rising. I don't know how crazy hot is it gonna be, how long will it take, but definitely it's rising. Now we're back to normal. Let's just hide the trails, head to planet Earth. There's something I need to show you. If we go to the properties of planet Earth, all right, we go to composition. These are the materials that our planet Earth is made of. Basically, like basic materials, all right? There are more detailed materials, of course, but basically, our planet Earth is made of that. There's a piece of information I would like to give you here. Our atmosphere, the air in our atmosphere is not 100% oxygen. We all know we breathe oxygen, all right? But oxygen is maybe, I don't know, like 21% of the entire atmosphere. It's not everything. It would be really a disaster if everything was oxygen. Now, my question is, what would happen if the amount of oxygen on planet Earth will increase in a crazy way? I don't want to change that manually. What I would like to do is this. We're gonna launch an object on our planet Earth. Let me first pause the time, go to launch. This object has to be, let's say, as big as the moon. I think that's not close enough. All right. I just needed to get close, then I'll pause time again and we will edit that. Okay? And stop. Okay? Now, let me set time back again, because when we play it again, we don't want that to go really fast. Now, I will go to the properties of this moon. Okay? And we are going to add oxygen to it first. And our moon is made of iron and silicate. We're gonna hide that. Again, I'm changing the properties of the moon. The radius has increased, but I think this should be exactly 1 moon mass. So the radius has increased because basically this is a giant ball of gas. There are no hard materials. That's why it looks bigger than the moon. But this is all a huge ball of oxygen heading to Earth. Now, we don't want, even if that's a ball of gas, still it will make a huge impact. We don't want that. We just want it to launch into the Earth really gently. So I'm gonna give it 0 kilometer per second speed and let the gravity of planet Earth attract it gently. Let's play time. All right. And I don't know, the app is going crazy kind of. Let's increase time a little bit and let the gravity of the Earth suck it up. Okay, stop. Like, I'm gonna pause the time here again and set the speed again to 0, because our goal here is not to make a huge impact. It's just to see the result of this amount of oxygen going into Earth. I'm gonna reduce time again. It's a little bit tricky because I don't want to miss the shot. So here we have impact. Okay, still it made impact fragments. This is logical. This is okay, but we did not do that huge impact on the planet. Our planet Earth has turned into this beautiful color. Let's check the properties of the planet. The temperature has increased really, really, really high. And is it still increasing? No, it's dropping now. Okay, let's hide the atmosphere individuals. And this is how our planet looks like now. This is where the impact happened. One more thing I would like to test on the planet, and the result again is going to be a disaster. Again, back to the properties. Now, if we look at the rotational period of the planet and the orbital period, we all know we orbit the sun once a year. We need about 365 days to make one entire rotation around the sun. What if, let's change that to days, all right? 366 days, basically, kind of. If we, let's pause time, our rotational period was only 1 day, like every day we celebrate New Year, every day we celebrate Christmas, how is our planet going to react? Okay, we seem to be really, really close now, although I still didn't play the simulation, but look at that. This is Mercury. Mercury is now behind us. Although it's the closest planet to the sun, we straight start to... We will just go really, really close to the sun. The temperature will definitely go crazy now. Okay, all right. Everything is steaming. Look at the reaction of our planet. Temperature is increasing slowly. Let's speed up time a little bit. Just a little bit. Yeah. All right. Our planet is cooking. Ladies and gentlemen, our planet is cooking. And here's the thing. Because the rotational period and the orbital period are the same, they both are 1 day, so our planet will be facing the sun in one direction the entire time. This is basically what happens with our moon. When it orbits our planet, it faces the Earth from one side only, because the rotational period again and the orbital period are the same, which is 1 day. So on one side, our planet will be literally cooking. Look at the temperature. That is crazy. That is hot. Life likelihood should be... Whoa. All right. There could be still life going on the other side. I don't know. Maybe very, very, very deep in the oceans. If there are any oceans left. I have no idea. This is definitely going to kill life on the planet. Yep. We are cooking from one side. Of course, it is really hot on the other side. Like, the lowest temperature is this one here. It's 180 now and still increasing. If we go even faster with time, yeah, at one side of the planet, we reached about 3,700 degrees. This is crazy. What about the life likelihood? Yep, at some point it will definitely reach 0. Let's zoom on. Whoa. All right, I don't like that. We all know that 1 day on our planet is about 24 hours. In Universe Sandbox, it shows it's a little bit less than 24 hours, but that's okay. We're not gonna look at these details. Now, here's the question. Let's change that into hours. See, 23.9 hours. The day and night changes once every 24 hours. Here's my question. What if we experience day and night every hour? Let's play the simulation. Temperature increase a little bit. Oh, the temperature is increasing. I just hit the play button. I didn't increase the time. Life likelihood dropped to 56%, and I think it's still dropping. Yep. Let's increase time now. Okay, check what happened. Okay, there are fragments coming out of the planet. My god. The oceans have all just, I don't know, have been driven to the center. I think that's what's called the centrifugal load. That's why. And there are fragments coming out of our planet. Life likelihood dropped to less than 3%. I don't know why the temperature increased. Maybe because the atmosphere will just vanish. Let's keep on increasing time and see what's gonna happen. Okay, our planet turned into a ball of fire. We crossed 1,000 degrees because, I don't know, maybe the atmosphere is just gone. Let's check the atmosphere. No, the atmosphere has increased actually. It did not vanish, it increased. It increased really crazy. Now we have, like, I don't know, it's about 4 times the atmosphere of Venus. Let's hide the atmosphere. Yep. Look how our planet looks like. This is definitely centrifugal low. This is the only amount of water we have on the planet. Everything else vanishes. ugly planet. There's still the the Hubble telescope orbiting the Earth, and they'll be like, Houston, can you hear me? Houston, you're spinning too fast. Houston, you're driving me crazy. Houston! Yeah, sorry, big boy. Planet Earth is no more. We saw what's gonna happen if we rotate once per hour, and now I'm curious, what would happen if we rotate once per second? Let's hit pause first, go to the properties of Earth, and play with the numbers here. Rotational period, let's change that to seconds. Based on Universe Sandbox, that's 68,164 seconds. That's how long is a year per second. Now, if we change that to 1, and hit play. Whoa. What? Okay, we're gonna replay that, but in a very slow motion. Before I hit the play button again, I changed the time speed. The speed of time is going now 10 milliseconds per second. So we're going really slow. Let's hit, okay. I don't know. Fragments, destruction everywhere. Whoa, we have torn the planet Earth apart. We saw that now, it was just like the real-time speed, second per second, but going slow motion, this is not something to see. I don't want that to happen to our planet. This is sad. If a day's long was 1 second, like if every second we had to witness sunrise, sunset, this is the result. We are going to vanish within less than a second. Yep. What do you mean life likelihood 0.113? There is no life, there is no planet. Yep. It disappeared. Planet Earth does not exist anymore. There's now... So the simulator is showing me the next object, like the closest object to Earth, which is a Hubble telescope. So this was all, ladies and gentlemen, for today's video. I hope you enjoyed the video. If you would like to know the result of any simulation, just write me in the comments section below what would you like me to experience in the future. If you like the video, please do not forget to hit the like button and subscribe to the channel. Thanks for watching for now, and I'll be seeing you in coming videos.